So this playing with dice activities is the one I rewrote into that Desmos activity. So we're not going to do it here, but this is the idea that you guys dealt with there. We're moving on to calculating our margin of error. So the margin of error for our confidence interval is calculated with this, exactly what I said before. Z star is basically giving us our number of bunny hops, right? How many we want to step away from our mean. And we've got our standard error, which is the length of our bunny hop, right? How far do I need to hop away from that particular value? Not really my mean, but my sample value in this case. So those are the two components. We do have two ways that we can kind of manipulate our margin of error, right, or make it smaller. One way is obviously to take a bigger sample. Having more information means my standard error is going to get smaller because it is harder to get away from that real value. I have more data centered or clustered right at the true value as long as we took a reasonable sample. But we're going to focus right now on the Z star. First off, Z star is called the critical value. It is technically just a Z-score. We're going to see Z-scores again in 6.3, and we're going to call them test statistics, and it's still basically just a Z-score. It's all about context and what we use to calculate them and how they're going to be used. But our critical value is based on our confidence level. And so this is that first question on the practice quiz. It was a question on the knowledge check, and I know some people were confused because this video was missing. So here is how we find our Z-stars. So essentially what we need to recognize is that when we have a confidence level, we're looking at a middle percent. We're going to use that to figure out how many bunny hops to go away. So in this case, we've got an 80% in the middle. And we know if we're doing a middle percent that we're going to have two Z's, a positive and a negative, because our Z's, right, I should be keyed about this, are centered at 0. We even have some ideas about this, knowing that one standard deviation or the Z-scores of plus or minus 1 is 68, plus or minus 2 Z-scores is 95. It's got to be between 1 and 2. Great. But we have two ways we can find this. One is we can just realize we're doing an inverse norm question, right? We have a percent. Z is a standard normal. I can do inverse norm. So we're going to do an inverse norm question. And we need a bit more. We need to remember that for our Z-scores, our mean is 0 and our standard deviation is 1. And if you're using the calculator, you need to do that little bit of step of, okay, if 80% is in the middle, that means 20% in the two tails, and that means there's 10% in each of these tails. And so you'd be doing inverse norm of 0.1 or inverse norm of 0.9. One note here about our critical value, they are always given out as positive, and that's just because we're going to end up adding or subtracting anyways, and we want to think of it as the number of hops that we're going out, so strictly positive in that regard. I, on the other hand, am not going to use that the inverse calculator, inverse norm in the calculator, because I think this one is just a little bit easier if I use the inverse calculator that we have online. Because the inverse calculator we have online lets me just say between. And it'll give me both the positive and the negative. I don't have to do two different steps. And I'm just going to grab this positive value of 1.282. So that's my critical value, my Z star for an 80%, 1.282. Now, hopefully, if you watch through videos that are later, you're going to find out that we also have, I don't think I have it open. I also have this T-table that I put under the resources module in your guys' Canvas shell. And here, the whole bottom row is your critical values for your Z star, and we want 80%. So that's way easier, but you'll notice in both the practice quiz and the knowledge check, I gave you confidence levels that are bananas, that no one uses, that are not here. So to find those, you're just going to use the inverse calculator online, throwing that in as a middle percent with a mean of 0 and a standard deviation of 1 in order to find your critical value. So that should catch you up. There is one last thing here to talk about because I started talking about the assumptions and conditions. I don't know if I covered this in that video, and I refuse to watch myself once I make a video. But a little bit more about that confidence level. When we set a confidence level, it's saying that if we did this a whole ton of times, we could have this percent of them catch the real value. So what should have happened when I had you guys all go out one standard deviation in that Desmos activity or one standard error in that Desmos activity, about 68% of you should have gotten the real value that I programmed in there. You should have gotten 35% inside of your interval. But that also means that 32% of you didn't. So about a third of the class didn't actually catch the real value when they only went out one standard error. And that was by design. I really wanted you guys to see that statistics is fallible. We don't necessarily get the right value. In a real statistic situation, we take one sample and we have one shot, and we don't know if we've done a good job or a bad job, or if we just got unlucky. So that hopefully is a takeaway that you had from that activity.